Welcome to your sterilization center. Today, IBA reinvents its product line and introduces the second-generation Rhodotron. All Rhodotron accelerators are based on the same operating principles and can be used for many different applications such as medical device sterilization, cross-linking, food irradiation, detection, etc. This video brings you to the heart of the Rhodotron, where technology meets expertise. You'll then experience the main steps of the sterilization process. For a few minutes, become the Rhodotron operator. It's easy. Sit down in the Rhodotron control room and let's start operating the machine. Before activating the beam, each subsystem needs to be switched on. The cooling system brings the water into the different elements of the accelerator. Two different cooling systems are used, one with deionized water and one with ionized water, depending on the subsystem that needs to be cooled. The water of these two closed circuits is cooled down by a chiller or an equivalent system. The heat exchanger dissipates the heat of each subsystem through the water cooled by the second cooling system. The cold water of this closed circuit is then distributed all over the machine on each subsystem. Now switch the vacuum system on. The vacuum on the cavity and the beam line is the first one to be activated. Rotary and turbo-molecular pumps remove the air inside of the machine and its components, including the beam line, to reach a high vacuum level. The same is done with the electron gun. This will remove the molecules of air that could generate collisions on the electron path. Now turn on the 9 magnets around the machine. The purpose of these magnets is to bend the electron beam and recirculate it inside the machine. As you can see, the activation of the radio frequency system happens in 4 different stages. A small signal is generated by the low-level RF rack, the signal is amplified by the pre-driver, then amplified a second time by the driver amplifier, and finally, a last time by the final power amplifier located on top of the cavity. This final amplifier is coupled to the cavity to generate the electric field in the machine. Thanks to the modular design of the second-generation Rhodotron, this complete RF chain can be doubled or tripled in order to provide a more powerful beam up to 700 kilowatts. Finally, you have to switch on the electron gun. The cathode, located on the left side of the Rhodotron, generates the electrons that are accelerated in the cavity. When electrons reach the inside of the cavity, the RF system produces an electric field between the external wall of the cavity and the central pillar. The electrons are therefore attracted by the pillar. When going through it, the polarity of the electric field is reversed in such a way that when traveling in the second part of the cavity, the electrons are accelerated a second time. After passing through the magnets where they're bent, the electrons are sent back through the cavity. At each pass, they're accelerated by a fraction of the final energy required. When reaching the final energy, the electrons exit the cavity by following their way straight forward through the beam line. If a lower energy is required, another beam exit can be chosen just by switching off the deflection magnet corresponding to this energy. The beam line transports the electrons up to the product to be irradiated. The 270-degree magnet bends the electrons. The electron beam is then diverted in the scanning magnet to create a curtain of electrons going out of the scanning horn to irradiate the entire boxes of products. When passing under the beam, the boxes are irradiated and the DNA of the bacteria included in the products are damaged by the electrons, preventing them reproducing themselves. When the right dose is applied, the treatment of the products is validated. The irradiation process and product traceability is completely managed through Beagle, the intuitive process control system developed by IBA. Before starting an irradiation, you have to prepare offline the treatment recipe associated to a product. You need to define all the parameters like the beam current, the speed of the conveyor under the beam, and the scanning length. All these parameters receive an upper and lower limit that define the validity of the treatment. After validating the treatment recipe, you need to create a batch order by associating a treatment recipe with a product or material and a path which defines the travel sequence of the product on the conveyor. After the validation of the batch order, the first box can be loaded. In order to track and identify the boxes during the process, each of them receive its own label. Dosimeters are also placed on some boxes to confirm the validation of the treatment by measuring the irradiation dose. The boxes are then sent inside the vault. The irradiation and Rhodotron vaults are completely secured to avoid anybody entering during the operation. To secure this area, different devices are installed to detect any intrusion that would automatically shut down the Rhodotron. In parallel, radiation level is monitored in both vaults at any time. The boxes are transported by the conveyor up to the irradiation section. The system avoids any gap between boxes so as to maximize the beam use. The boxes then pass through the electron curtain. The treatment parameters are recorded by the process control system and can be consulted at any time. When the irradiation of the first side of the box is performed, the boxes quit the irradiation vault. If the treatment is completed, the boxes are directed to the unloading station. The dosimeters are then analyzed in the dosimetry room to validate the treatment by measuring the dose received by the product on its surface. In case they need a second side irradiation, the boxes remain on the conveyor, pass through a flipping machine that rotates them, and are re-injected in the main loop to be irradiated a second time. If the treatment parameters are not within the predefined limits, the boxes will be rejected. At the end of the process, a report is generated for each batch order, including all the recorded treatment parameters. Once they arrive at the unloading station, the boxes are repalletized for storage or direct shipment. This flexible and fast treatment allows you to perform your sterilization faster and more cost-efficiently than any other technologies without any gas residuals or radioactive material involved.